finding the inverse of a function, you just have to have the appropriate algebraic strategy to switch the x and y of your function. So let's say you have the first function f of x equals 2x plus 3 all over x minus 1. So the first step always, that's the standard to put your function in the y form. So y equals 2x plus 3 all over x minus 1. Now the second step is to switch your x and y. So this y becomes x, and this 2x here will become y. Okay, now you wanted to isolate the y, so you don't need a fraction. So to remove the fraction, if you have a fraction on the left side and a fraction on the right side, you need to cross multiply. So all over 1. Okay, so multiply x and y minus 1, and then 2y plus 3. Now remember, when you cross multiply, the reason for it is for you to remove a fraction. So to make another fraction is actually not logical. Okay, now to isolate y, we need to free y here first. So you always have to go along with the flow. If it asks you to multiply, you multiply. If it asks you to add, you add. That's actually the secret to manipulating rational expressions. So you distribute x to y minus 1 because it tells you to do so, and another thing because you want y to be out of the parentheses. So you have xy minus x is equal to 2y plus 3. Okay, and then after that, you need your y to be together and the others to be together too. So you need these two to be together. So remember, when a certain expression passes the equality sign, it changes to its opposite sign. So x also had to have to move to the right side of the equation. So 2y will become negative on the left side and x becomes positive on the right side. Okay, then after that, because I need y, as you can see, I cannot simply combine xy and 2y. They are not similar. So what we can do here is to factor out y, the expression, and what remains inside the parentheses will be x minus 2. So if I'm going to distribute y to x and to negative 2, it will go back to its original form. Or you can simply divide each expression by y. So xy divided by y is x, 2y divided by y is negative 2. So equals x plus 3. Since y is by itself already, what we can do is to divide the whole expression by x minus 2, and it cancels out. So therefore, it now equivalent to x plus 3 all over x minus 2. And of course, this is the inverse function, not the function itself. So they are different. So since this is an inverse function, you need to express it really as an inverse function of x, which is equal to x plus 3 all over x minus 2. Okay, to prove whether you are correct or not, you can actually do this in the graph and make y equals x as your line of symmetry. You would see that the two graphs are symmetrical from the line y equals x. Now, let's go to the second example. Okay, so you have f of x equals x squared minus 4x. So the first step is to switch your x and y after making your f of x equals y. So switching that, it'd be x equals y squared minus 4y. Okay, now remember, it's just not the single x, it has to be both x's. So both of them becomes y. Now, I wanted to isolate y, but I cannot simply combine 4y and y squared. I cannot also transpose negative 4y because the principle here, you have to put the y together and the x together and everything else. So these are already together. So there must be a way on which I would be able to like take this out because you see, if I'm going to add 4y here to take out the 2, I need to square root x plus 4y. And that's not possible. I want to isolate y. With this situation, you can do the completing the square process. Okay, now how do we do that? Okay, so we will divide b by 2. So our b is 4. And divide by 2 regardless of the sign, and you will have 2. And then after that, you square it, and that's 4. So it makes it a perfect square or a perfect square trinomial. So this now becomes, but remember, when you add it to the left side of the equation, you should also add it to the right side of the equation. So you see, if I'm going to subtract 4 on both sides, it goes back to the original form. So algebra is like that. Whatever you do with it, as long as you don't change the value, it's all right. So now this is now a perfect square trinomial whose factors are square of a binomial. So what will be that? And that would be the square root of 4, which is 2. And just follow the sign here. Now, why is this possible? So you see, if I'm going to multiply y minus 2 and y minus 2, we have y times y is y squared. Y times negative 2 is negative 2y. Negative 2 times y is negative 2y. And negative times negative is positive 4. So it goes back to y squared minus 4y plus 4. So by principle, when you factor the perfect square trinomial, you just simply take the square root of the first term and the square root of the second term and square that. So it becomes a square of a binomial. And this will be x plus 4. And so as you can see, we can remove now 2. Unlike when it was originally here, you cannot simply remove that square out there. So by simply raising the whole equation to 1/2. And so therefore, 2 of 1/2 is 1. So what remains on the left, on the right side is y minus 2. And you have x plus 4 raised to 1/2. And also remember, if it's raised to 1/2, that means you're taking the square root, because I've told you before, radicals are expressions with fractional exponents. So this now becomes x plus 4 square root. But you see, you have to take the positive and the negative of that, because if you have 4 square, is 16, and negative 4 square is also 16. So therefore, if you square it, if you take the square root of this, you'll be positive and negative, okay, because you're taking the square root. Now after that, we can isolate now 2 by adding it on both sides of the equation. We can isolate y. So this is cancelled. So therefore, you have y equals 2 plus and minus the square root of x plus 4. Okay, since I don't have a restriction, sometimes maybe I could restrict it that my x is greater than or equal to negative 4 or something like that. I don't have a restriction. You should indicate that this will be the inverse of the function. So therefore, the inverse of the function, so I will have to erase this. I don't have space. So the inverse of the function will be f of negative 1x is equal to 2 plus and minus the square root of x plus 4.